So we have our diamond that we use for the softball field, which is really just a square, kind of turned on its corner. And each side is 60 feet. Each angle is going to be 90.
Wait, what would it be? Oh, it would, okay.
See, if it's just kind of turned on a corner.
Yeah.
All right, and it tells us that the pitcher's mound, which is not in the middle, it's not in the middle between first and second base, but the pitcher's mound, let's say, is right here, and it's 43 feet from home plate. We want to find the distance from the pitcher's mound to first base. So if each angle is 90 degrees, what is this angle? 45. So what formula do we need to use to find out how far it is from pitcher's mound to first base? You have,
Wait, where did she get 45?
it's 45 degrees because each angle is 90 degrees. And the pitcher's mound is
Oh, right.
going to cut it in half.
So
Can you
it's
use
an
the law?
included, so it's all.
Two sides and included angle. So law of cosines. And we are looking for distance. So our distance is the square root of 60 squared. Doesn't really matter which one I put first. Plus 43 squared. Minus 2 times 60 times 43 times the cosine of 45. And if you plug that in your calculator, notice I like to go ahead and solve for d instead of d squared. If I go ahead and put in my square root to start with, then I won't forget it later.
Can't you use the law of sines to do like d over 6, or d over the sine of 45 is equal to 60 over the sine of 90? Or something
Whoa,
like
that
that?
just like,
No, it's not 90 because she said
It's not halfway. It's not in the center.
Oh, oh.
Did y'all get 42?
I got 42.43.
42.43 feet. That's a good question though, James.
Is the
You're
line-
thinking anyway.
Is the line from first base to the mound, does that cut 90? So would that be 45 as well?
Not necessarily,
Because it's not.
because it's not in the center.
Okay.
Same thing.
Yeah, just like
Okay, so 42.43 feet. Helps to draw your picture. Or it does help me to draw the picture. I don't think I could do it very easily without having a visual. Any questions? Let's look at our second one.
that. I don't like these.
It's not bad. Okay, it tells us that a ship travels due east and adjusts its course northward. It doesn't give us a bearing, it just goes northward, not due north. Due north would be a 90-degree angle, but northward.
That's nice.
And then after traveling for 80 miles in that direction, it's 139 miles from its point of departure. We want the bearing from the point of course change to the final position. So let's think about it. If we start right here, let's just go ahead and call this A where we start. That's where the ship starts. And he travels 60 miles due east. And at that point, he changes direction. So we'll just call it B because it's just a point of reference. And it goes northward. If it said due north, I'd go straight up, but it's just northward. So he goes about 80 miles. That may not be the exact direction, but 80 miles. And it tells us that after traveling 80 miles, it's 139 miles from the point of departure. We departed at A, so this is 139 miles. And what we want is the bearing from the point of course change to the final position. In other words, this is where he changed course. And the bearing is from a north-south line, so that's what we're looking for bearing. Any suggestions?
We're solving for like cosine of B, right?
Right, we need to know what angle B is. So if we find the cosine of angle B, that's going to be just, in general, a squared plus c squared minus b squared
Bless you. Bless you.
Thank you.
over 2ac. Okay, so we'd have the cosine of b equals 80 squared plus 60 squared minus 139 squared divided by twice 80 times 60. That doesn't go there. So what is angle B? You plug it into your calculator.
$166.1528125.
Is he right?
That's what I got.
166.15 degrees.
Yeah.
Everybody get that? Not hearing any comments.
Yes, I did.
Kat did, James did.
You subtract from 90?
Well, you subtract 90 from that, but why do we need to subtract 90 from that?
Because it's like north-south line.
Because we need a north-south line. We know that this side is 90 degrees. So if we subtract 90, we're going to get,
76.
where did that come from?
Oh.
Okay, what do I need with that if I'm looking for bearing?
Isn't it gonna be?
Wait, what
E?
angle
Wait,
is?
no.
North and
East?
east. So that's your bearing.